Welcome to STEM Baba. In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James's Walker. So let's start. Now, in this question, we are given that a particle leaves the origin with an initial velocity of 2.40 meter per second x cap and moves with a constant acceleration minus 1.90 meter per second x cap. This is the x component plus 3.20 meter per second y cap. So this is the y component of the acceleration. Now there are three parts in this question that we need to solve. In the A part, we need to find how far does the particle move in the x direction before turning around. So when the particle turns around, the x component of the velocity will become 0. So to solve the A part, what we can do is we can equate Vx to be equals to 0. And I'm going to use this equation in the x direction, which is Vx square is equals to V naught x square plus 2ax delta x. And we can equate this Vx to be 0. So 0 equals to V naught x. We have the initial velocity is this. This is 2.40 meter per second and its whole square plus. Now 2 times the x component of the acceleration is minus 1.90. So minus 1.90 meter per second squared times delta x. From here we can easily find the value of delta x, and delta x from here comes out to be as 1.52 meter. Therefore the particle travels 1.52 meter before turning around. Okay. Now next in the B part, we need to find the particle's velocity at this time. So at this time Vx becomes 0. This we know. Vy, we don't know what the velocity at this time in the y direction. So first we'll calculate the time at which this Vx becomes 0. And for that we can use this equation. Vx is equals to V naught x plus ax times t. Now equate Vx to 0 so that we can find the time. So 0 equals to V naught x, we have 2.40 plus acceleration in x direction we have minus 1.90 times t. So from here time t comes out to be as 1.26 seconds. So at this time the particle will turn around, or you can say that at this time the x component of the velocity becomes 0. Now at this time what would be the y component of velocity? Simply Vy is equals to V naught y plus ayt. Initially there was no component of velocity in the y direction, so this term is 0. Ay we have 3.20. So 3.20 meter per second squared multiplied with time we have 1.26 seconds, and from here we get the y component of velocity to be 4.03 meter per second. Now at this time Vx is 0. At time t equals to 1.2 seconds, Vy we have this value, Vx we have this value. So what would be the velocity at this time? So velocity will be V equals to Vx x cap plus Vy y cap, and there is no x component of velocity at this time, so this is 0. Only we have the y component, which is 4.03 meter per second. So this will be the velocity at this time, because this Vx is 0, so simply the y component will be the velocity. Okay. Now next in the C part, we need to plot the particle's position at these several time intervals, and we have to sketch the graph also. Okay. So to solve the C part, I'm going to use the equations x equals to x naught plus V naught x times t plus 1 over 2 ax t square. This will give the x position at given time, and for the y position we can use this equation y equals to y naught plus V naught y times t plus 1 over 2 a y t square. Now we have to find the position at time interval 0.5, then 1, 1.5, then 2 seconds. Okay. So at time t equals to 0. So at time t equals to 0, x is 0 because x naught is 0 here. Similarly, at time t equals to 0, y is also 0. Now what would be the position at time t equals to 0.5? You can put all the values here. So x is equal, x naught is 0, V naught x. So V naught x, the initial velocity we have 2.40. So this is 2.40, time is 0.5, acceleration is This is 1.1 over 2. Acceleration ax we have minus 1.90. So minus 1.90 multiplied with 0.5 and its whole square. So on solving this, we'll get the value of x to be 0.9625. So this is the x value at time t equals to 0.5. Similarly, what would be the y position at time t equals to 0.5? Put all the values here. So y equals to, we can directly put the values. Y0 is 0. V0y was 0 because there is no initial velocity in the y component. So this is 0 plus 0. 1 over to ay. Now ay we have 3.20. So 3.20. Time we have 0.5 and its whole square. So on solving this, we'll get the value of y to be 0.4 meter. Now in the similar fashion, we can find all the x and y values for different time interval. Now I'm going to plot the table. So this is the table. Now at time t equals to 0, x we have 0. Similarly, at time t equals to 0, y is also 0. At time t equals to 0.5 seconds, x we have calculated to be 0.9625. And this value is 0.4. Now similarly put this time as 1 here to find the x value, and we'll get the x value to be 1.45, and then we'll get 1.4625, and finally at time t equals to 0, x is 1 meter. In the similar fashion, y we have at 1, this is 1.6, at 1.5 y is 3.6, and finally this will be 6.4. Now we can easily plot the xt and the yt graph. So I've plotted all this coordinate here. This is the xt and this is the yt graph. Now join all these points with a smooth curve. And similarly here also. So these graph shows the position of the particle at a given time. Now in this question we are given that an athlete launches a basketball from a stadium platform that is 16.2 meter higher than the hoop. So this vertical distance is 16.2 meter, and he makes the basket by launching the ball at an angle 14.5 degrees above horizontal with a speed of 11.6 meter per second. So he throws like this at speed 11.6 meter per second, and this angle theta with the horizontal theta is 14.5 degrees. Now we need to find the horizontal distance traveled by the ball when it passes through the hoop. So let me first show the trajectory of the ball, and we need to find this distance. Let this distance be x. This distance we have to find. Now to find this distance, I'll be first find the time taken by the basketball to reach the hoop, and for that I'm going to consider the vertical motion of the basketball. So I can use this equation, y equals to y0 plus v0 y times t plus 1 over 2 a y t square. And let me show the coordinate system also. So I will measuring the distance from here. This is the x-axis and this is the y-axis. Now initially the football or the projectile is at a distance of 16.2 meter. So this is 16.2 meter, the y0, and y becomes 0. v0 y we have 16 sine theta. Theta is 14.5 degrees. Acceleration ay we have minus g. So minus 1 over 2, I'm writing it here. Minus 1 over 2, g is 9.81 and times t square. And one thing I missed out, this should be multiplied with t. Now from here, we can solve this equation. This is a quadratic equation, so we'll get time to be equals to t equals to 2.13 seconds and minus 1.54 seconds. Now this time is neglected, we have to take this time. So the time taken by the basket to reach the hoop is 2.13 seconds. Now we can easily find the x value, the horizontal distance traveled by the ball. So x is equals to x0 plus v0 x times t plus 1 over 2 ax t square. We can use this equation. X0 is 0 and v0 x we have 11.6 cosine theta. So 11.6 cosine theta multiplied with time. Time we have to take to be 2.13, and there is no acceleration in the x direction, so this whole term is 0. Now from here the x value comes out to be as 23.9 meter. So the horizontal distance traveled by the ball is 23.9 meter. Now in this question we are given that in an experiment 2 marbles are launched at the same time, and the marble is launched horizontally with a speed of 4.20 meter per second from a height 0.950 meter. Now the marble 2 is launched from the ground level with a speed of 5.94 meter per second. So this is the speed for the marble 2, which is 5.94 meter per second, and for marble 1 it is thrown horizontally with a speed of 4.20 meter per second. Now there are two parts in this question that we need to find. In the A part, we need to find where would the marble collide in the absence of gravity. That is, we have to find the x and y coordinates of the collision point. So in the absence of gravity, the marble 1 will continue to travel in the horizontal direction in which it was thrown. Similarly, the marble 2 will continue to travel in the same direction in which it was thrown. This angle theta we have 45 degrees as per the question. So suppose that they collide at this point. Now we need to find the x and y value of this point. Now to solve the A part, we're going to first consider the vertical motion for the marble 2. So y we have the speed, initial speed, which will remain constant throughout the motion, multiplied with time, which is basically TC here, because this is a time of collision. Now think what would be the final position for the marble 2 when it will going to collide. This y will nothing but this height, because at this height they will going to collide. So this we can equate to be h is equals to v naught y, we have v naught 2 sine theta multiplied with TC. Now from here TC would be equals to h over v naught 2 sine theta. We can put the value here to find the time of collide. So h we have given to be 0.950 meter, v naught 2 we have 5.90 sine theta, and theta we have 45 degrees. So on solving this, the time of collision come out to be as nearly 0.2262 seconds. So at this time they will going to collide. Now what would be the x position for the marble 2? x2 will be equals to v naught x for the marble 2 multiplied with the time of collision, and v naught x2 we have v naught x cosine theta multiplied with time t. So v naught x we have 5.94 cosine theta is 45 degree multiplied with time is 0.2262 seconds, and from here this x2 comes out to be as nearly 0.950 meter, and the y value will itself the h value, which is 0.950 meter. So these are the x and y coordinate, and we have find out the x and y coordinate for marble 2. If you calculate for the marble 1, you will get the same value. X1 will also 0.950 and y1 will also 0.950 meter. So these are the answers for the part A. This is the x and y coordinate. Now next in the B part it says, where do the marble collide given that gravity produces a downward acceleration of 9.81 meter per second squared? So this time we have to consider the gravity. Now to solve the B part, what I'm going to do is I'll equate the y positions of the two marbles. So equate the y positions. So we have y equals to, this is the marble 1, so y naught 1 plus v naught 1 in the y direction multiplied with t minus 1 over 2 gt square. This is for marble 1. Now for marble 2, y will be equals to y naught 2 plus v naught 2 in the y direction multiplied with t minus 1 over 2 gt square. This is for the marble 2, and we know that these y coordinates are equal, so we can equate these two equations. So we can write that y naught 1 plus v naught 1 in the y direction multiplied with t minus 1 over 2 gt square is equals to y naught 2 plus v naught 2 in the y direction multiplied with t minus 1 over 2 gt square. So this term and this term will cancel, equal. Now y naught 1 is the initial position for marble 1. Now initially the marble 1 is at this position, which is 0.950 meter above the ground. So this is 0.950 meter. Plus, now there was no velocity of the marble 1 in the y direction because it was thrown horizontally. So this term is 0. So we can equate it to equals to y0 2 is 0 because initially it was thrown from the origin. So y0 2 is 0. And what was the component of velocity in the y direction? It was v0 2 sine theta, which is basically 5.94 sine 45 degrees multiplied with t. And this t is the time of collision. So from here we can easily find the time of collision, and it comes out to be as 0.2262. So they will collide at the same time. Whether if there is gravity or not, the time of collision is same in both the cases. This is a very important point here. Now what would be the x and y coordinate? You can use the simple equations. So for the marble 1, I'm calculating x1 will be v0 1, the initial velocity in the x direction multiplied with the time of collision, that is 4.20 multiplied with 0.2262, which is equals to 0.950 meter. Now what will be the y1? Y1 will be equals to, here this is, we can use this equation, y0 1 we have h, and this value is 0. So h minus 1 over 2 gt square, we can use this equation. This is h minus 1 over 2 gt square. H we have 0.950 meter minus 1 over 2, g is 9.81 meter per second squared, multiplied with t is 0.2262 second and its whole square. So from here we'll get the value to be 0.699 meter. So these are the coordinates where the marble 1 and marble 2 will collide. I've found the coordinates using the marble 1. You can calculate the coordinates by using the marble 2 also. You'll get the same answer. So finally we can conclude that the x and y coordinate we have. So this is 0.950 meter, comma 0.699 meter. Now if you see the similarities, you will see that the time of collision in both the cases is same. Here also we obtained the time of collision to be 0.2262 seconds, and here also the time of collision is 0.2262 seconds, and the x value is also same, 0.950 meter. But the y value is changed because of the acceleration in the vertical direction. That is why this value is changed, and x values remain same because there is no acceleration in the x direction. So this is the final answer. Now in this question we are given that a football player kicks a field goal launching a ball at an angle 48 degrees above horizontal. So theta we have 48 degrees, and during the kick the ball is in contact with the player's foot for 0.045 seconds and the ball's acceleration is 290 meter per second squared. So we have to find the range of the football. Since the ball is in contact for this much of second and the acceleration is 290 meter per second squared, now what would be the initial velocity? V0, which will be acceleration times t. Acceleration we have 290 meter per second squared, and time of contact we have 0.045 seconds. So from here initial velocity we obtained to be 13 meter per second. Now theta we know, we have to find the range. We can use a direct formula. We have solved multiple problems like this. It's pretty simple. You can simply use this formula and put all the values here, and finally we'll get the answer after putting the values to be 17 meter. So this is the answer.